In this video, we're going to talk about circuit design. And there are a lot of circuits or the electronic circuits probably in your home. If you're curious, you may just, you can open up some of the gadgets you may no longer use and just see what's inside. You're going to find, various kinds of circuit boards, in fact. And here's an example of a circuit board. And this is a very tiny circuit board. This is actually the iPhone charger. The iPhone charger, if you have seen this, is a very small, for power adapter. And inside that little small container of plastic, and if you open this up, you'll find there are actually two circuit boards. There's a primary one, there's a secondary one. This one that I'm showing here is the primary one. And then there also is a bunch of other components in the middle. So, and you'll see a typical circuit board. This is a very small one, and then you see a size of mustard seed, and then this is actually a grain of rice. And so the whole board is, smaller than the quarter coin. And on this board is made of mostly silicon and copper and plastic. If you look close enough, you'll see the thin lines, like the color of a copper, and that is, basically is the channel for the electricity to flow through. And also, you're going to see a bunch of integrated circuits or ICs that has some special function that's built in. They are miniature sized, typically, mass produced, usually in different places. I don't know if you can see over here, this is actually a tiny little resistor here. And now the Raspberry Pi is just a little bit bigger, obviously. It's a little bigger board. This board is still fairly compact. It's got the major components of a typical computer. And the Pi can be considered as a sort of general purpose computer, obviously, because it's powerful. But then, really the purpose of the Pi is mostly educational value, or for prototyping. You can experiment your ideas, and then you can try it out with the Pi. And the primary mechanism for us to modify or extend the Pi physically with some additional components is through this GPIO header right here. There are 40 pins on this Raspberry Pi model. And we're going to take a closer look at those pins, by the way. This is going to be the place where we're going to connect to our circuits to build simple functions. And this is so we'll take a closer look at that. And then this is simply, and again, last time I can explain the major components on this board. You got this, is the Broadcom chip. It's also got a system on chip. It's got multiple things integrated into this thing. You got a quad-core CPU and also GPU inside. It's got a bunch of I/O functions. And then this is where the RAM is. And then you have a bunch of ports, of course. And then you actually have other ports here. This is for connecting a display, and this is for connecting a camera. And this little chip here by the GPIO pins is the Wi-Fi and Bluetooth module. So this is an image of some of the stuff that you've got in your IoT kit that you picked up. Let's see if I can make this a little bigger. Let's take a look at some of the things that you've got. So, on the top row, you see those are the things actually part of the pie. We already assembled them. And you have seen there's a couple of buttons here. Actually, if I can make this a little more bigger. There are smaller buttons. There are actually a large button as well. And the button is an input device. We can provide a signal by pushing the button. Then there is also LED screen, and this obviously is an output device that we can display information on this screen. And then this is a buzzer that can produce a sound. And then we've got this GPIO cable, and this cable allows us to, so you saw on the Raspberry Pi, all those pins over here, and if we're gonna connect things to this, and it's not very convenient to plug things on and off, working with that board. I mean, you can, but for our purposes, we're going to actually use the cable to extend those pins out. And then those pins will be, one end of the cable goes to those pins on the board, and then the other end goes to this GPIO breakout extension board. And so this has also got a 40 pins over here. So this way, and then this thing actually we can put this on top of the breadboards, and the breadboards are essentially just a simple device where we can build our circuits without soldering, just kind of using these holes and connect them with the jumper cables to build our circuit. And then we're going to take another look at what's inside of the breadboard so you understand what those holes mean and how we're going to use this. Let's take a look at some other components here. There's this ultrasonic sensor. Ultrasonic sensor is also the proximity sensor that are more commonly known. And if you have a Nest thermostat at home, you probably see how that functions. This is also inside a typical Nest thermostat. When you approach the thermostat, and then the screen will light up because it is able to detect the presence of an object. And so this is what this ultrasonic sensor allows you to do. And this is in the little bag, and the motion sensor has a round cap, and it provides a kind of wide angle view of the motion in a certain range. And so the motion sensor, you may already have those at home if you have a smart home devices. And these long legs with a little thing in the middle, actually they're striped, colored, and those colored bands actually indicate we're going to learn how to read the value of those resistors, the value of the resistance. So it's measured in ohms. So you see there's a bunch of different sized resistors from 220 ohms to all the way to 10,000 ohms. So when we build our circuits, we're going to use resistors. Typically, the resistors are a way to protect the components on the circuit, not to have too much current going through them. And then it steps down, the voltage in the circuit. In some circuits, we're going to use them. So this is those are the resistors. And then this is a RGB LED, and this LED it allows you to, it has multiple legs here. Actually, it looks like a 4. And this allows you to control the color of the LED to, red, green, and blue. And then there's also individual LEDs you see in this bag here, different colors, red, green, blue. Those are individual LEDs that only have a single color, either lights up or not. And then of course there's also intensity of the light you can control as well. These are the jumper cables that we use to connect different components in a circuit. And then we also have another input device called keypad. So the keypad allows us to input multiple signals through those buttons here on this keypad. Okay, so we'll be using most of those components. Actually, well, there's a couple more components the school is ordering. I don't know when they're gonna arrive, and I'll let you guys know when they do arrive. So we're gonna start using. Okay, there's a couple more things here. So this is the servo motor. The servo motor allows you to, for example, this plastic spindle here. This can turn. There's a little motor here, so when you connect this to your circuit, this part will spin, and then you can put a little needle here so that you may use this to move as a indicator. Allows you to show different values, for example. So that's kind of the stuff that you got so far. All right, let's take a look at. All right. This is what the inside of the breadboards look like. So typically you have a rows of 5 holes, and those 5 holes in each row, they are connected. So they're actually on a single piece of metal. And then the vertical stripes, the long ones that's marked positive and negative, those typically used for power. This positive voltage goes to this one marked the positive, and the negative will usually connect to the ground. And this are just kind of convenient things for you to build your circuit, and then you don't, just this whole place, you're free to use wherever you want to put your components. Then the GPIO is kind of the primary interface we're going to use to build our ad hoc circuits. And the Canon kit came with a reference card that shows the arrangement of the pins. And let me explain these things a little bit. So you see there's in the middle, you got those numbers marked 1, 2, 3, 4, all the way until 40. These are the physical pin numbers. The physical pin numbers are typically not used in our programming, but they are obviously easy to find because they're in sequential order. And if we're gonna talk about where to plug in a certain component, what goes to which pin, we may reference the physical pin number when we talk about the physical components and we build out the circuit on the breadboard. Now, when we program, most often we're going to use the GPIO pin numbers, and these are also they're called the BCM pin numbers. The BCM stands for Broadcom, and the GPIO pin numbers are, when we use a Python library like rpi.gpio or the GPIO 0. And so we're probably going to use those GPIO pin numbers as a default. So you'll notice there's names marked as well, not just the numbers. There's also some of the pins that won't be marked with a certain name. Like, for example, this has these names here, the SDA, SCL. Those are names named based on the functionality of those pins, that you can use them for a certain function if you want to do that, or you just use them as generic pins that you can build your circuits on. So what we do, we need to use some of those special functions. We're going to mention those, but for right now, you don't have to worry about those names yet. And then there's a special names of course, we need to recognize. First of all, where do we supply power to our circuit? So we'll have these voltage pins. There's a 2 5 volts pins right here at this physical location 2 and 4. And then we also have a two 3.3 volt pins. And so the number one, physical number one, and the 17 right here. And okay, by the way, where is number one on the physical board? Let's go back to take a look at this image. So in the way this is positioned, you see this USB port right here, this Ethernet port, and pin number one is right here, top left corner. This is pin number one, and a 1, 2, 3, 4, 5, 6 that way, and go all the way to number 39 and 40. Okay, that's how that's arranged on the board. Now, we're going to use the extension cable. So we're not going to be using, looking at this when we're building our physical circuits. We'll be actually having that laid out on the breadboard with the extension board. Okay. So one thing to note is that the 5-volt pins will be used rarely. In certain situations, we may use them, but most of the time, all the circuits are going to be using 3.3 volt electricity in the circuit, right? So just kind of keep that in mind, because if we're dealing with the 5 volts, then we'll have to use certain protective devices. Make sure that you're not damaging the pi itself. Okay. And then to complete the circuit, the current needs to flow into these ground pins. There are actually 8 in total ground pins that are marked typically black color. And since we're going to use the breadboard, and then we're going to actually have plenty of holes to use on the board by just connecting to one of the ground pins. And then, so that's it. That's what I want to talk about this pinout of GPIO. Now, each individual pin potentially has a circuit, something like this behind, that allows us to be able to program that pin to be an input pin or input pin. And so the circuitry behind that might look like this. And this is a schematic circuit. And so some of the symbols you have seen, for example, this is diodes. This is obviously the ground symbol, and this connects to a 3.3 volt DC power source. And you have some integrated circuits here that perform different functions. And then you may have some transistors here, and then connected to another component that's doing a pull up or pull down with the resistors to control and which input to go to. So, and this is quite low level. This is built into the board on the Raspberry Pi, just kind of for, if you're curious, right? So this is potentially what's behind the pin. Now, we are not going to be using the schematic diagrams much, but we may occasionally use them, or if you see them, you should be able to recognize some of the symbols. For example, we have a look at the resistors, maybe represented this way, or the way like this. This is the US version, this is the international version. Mostly we're going to use the US version in our schematic diagrams that you see. And there are different kinds of resistors. There's even variable, and so I'm not going to talk too much about those. You may have switches, and so when we do encounter them, I explain more about what they are and what do we use them for. And then you have a logic gates, and then the whole the logic, the CPU is built with huge amounts of logic gates. That's providing this sort of the binary arithmetic that's implemented with those logic gates. Okay, so you kind of you probably will see those quite a bit. And these triangles here, like this with multiple ports. These are typically the integrated circuits, and then specifically the operational amplifiers. So we're not, really studying the low-level electrical engineering components. So we're going to skip them, just so that you're familiar with them when you see what they are. Now, instead, when we draw a diagram, when we design a circuit, we're going to mostly use this tool called Fritzing. And it's a free software. I will show you how to use it, how to install and use it in the next video. And so this is it's going to be the first. This is the circuit for so-called the hollow well circuit. It's kind of the simplest kind of circuit that we're having, single LED light and connected to a resistor, and that connects to your Raspberry Pi. Now, in this circuit here, we're going to basically, directly connect to the Pi, this GPIO pins directly. Now, although when we actually build it out, we're going to use the extension boards, all right? So I'll show you how those things. So first, we're going to learn how to design a circuit and draw it out before we build out the physical circuit, and then start programming and to control the circuit. Now I show you how to design a circuit with a tool called Fritzing. First, we need to install Fritzing. This is the spelling. We'll search this and then click on download. And you'll notice that it asks for a donation for the download. So if you don't want to donate, what you can do is that you sign up a free account. Click on this sign up. And they give it a username, email, password, and then complete this CAPTCHA. And then you can create a user. So I've already created my user, so I'm going to simply just log in. And now you click on this download tab. And since you don't want to pay, you just say, I already paid. And then click on download. So now you have a couple of links for different operating systems. Most of you are on Windows, so I'm going to just show you how to do this on Windows. And I'll choose Windows 64-bit. Save file. Oh, I guess it's completed. So you open this file. And do you want to launch? Yes. Next. You can say only for me or everybody. I mean, it doesn't make a huge difference if you're the only user on your computer. Next. Install. All right, it's done. So I'm not going to launch it right now. I'll just click on finish. And I just see if I can find this way. Normally, I'll just open this with type in the word Fritzing in the Windows search bar. And then click on this app. So there you have it. And then just double click and to make this a little bigger. Now, and this part you see the top right corner are the parts menu, where you can find the electronic components you can put onto your circuit. And then this is the inspector, which shows the properties of the component. And then you have a couple of tabs here. As you see, you can design a circuit on a breadboard or on designing a schematic, for example. So we don't really have anything here. And maybe if you want to do that, you can even design a PCB, printed circuit board, and you can even order that to have them manufacture for you if you want. But mostly we're going to be using the breadboard view. And so here you see this already has a regular sized breadboard that you have seen. This is the kind that you have. And to make our circuit a little smaller, I typically don't use the large one. I'll just use a small one. So you search for breadboard, you'll see there's many different kinds. So typically I'll use the mini breadboard. Okay, so right there is a small one, but I'm gonna just delete this one first. You essentially just, click on, you select it, and then just press the delete key on your keyboard. Then I'm gonna drag this mini breadboard onto this workspace, okay? And then of course we want to have the Raspberry Pi. So I'd like to use the Raspberry Pi 4B. So here, actually there is one right here, right? So Raspberry Pi 4B, this is the one we have. To drag it onto here. All right. You can make this a little smaller if you want. If you want to put more stuff in here in the same view. Now, we want to connect a very simple circuit. The circuit will have a resistor and an LED. And we're going to just use the example in the book for this Hello World simplest kind of a circuit. And we'll use a ground pin, and we'll use a GPIO 18, just what the book says, and we're just going to use that same thing. Okay, so you hover over these pins, by the way. If you hover over them, it's going to show you what that pin is, and it's very convenient. So it helps you find, so what we're going to do is now is so let's say we're going to first connect the ground. Well, actually, let's connect the GPIO 18 to the breadboard. I'll simply just draw a straight line to the breadboard. Now remember, these sets of 5, they are connected together on the same metal. Okay. So this is where the volt, but this pin can output a volt, 3.3 volts electricity to it. As I mentioned earlier, most pins are going to be giving you 3.3 volts electricity for your circuit. Now, so we're going to connect, let's say, this is essentially saying we have a jumper wire from this GPIO 18 to this breadboard. And now we're going to add a LED over here. Just search for LED. We just simply pick this one that looks like the plain red LED right here. Okay. So we'll drag this. It has two. So by the way, it has two terminals. The longer terminal is so you have these two terminals. One is called cathode, one is called anode. The anode terminal is where the electrons leave. If this is where the electrons leave the device, that also means the current flows through it from this leg, from this terminal. And so this is actually the positive, because current flows from positive to negative. And so we're going to actually position like this. You see this is a little twisted here. The actual LED you're going to see it's going to be, this is the sort of like a little longer leg. And this typically is the positive terminal, or it's called the anode, all right? So we're connecting from this pin through a jumper cable, and this breadboard, on the breadboard, these holes are all connected. So to arrange this, make a little more, I like to use more space so it's easy to recognize. And I'll put this in the far end of this holes here. And this is still the electricity, the current flows this way. This is where the voltage starts, the positive voltage. And then we have, this is the anode terminal through LED, and it will light this LED up and then onto here. And now we want to add a resistor to the circuit to prevent, too much electricity going to the LED. So let's add a resistor. So as you notice, there's a lot of them. And in fact, there's one that's 220 ohms. And so in your kit, you have many different ohm value resistors. And you do have a 220 ohm. So let's just use this one and drag this over. Okay. So now you see we're connecting. Again, these two holes are connected, right? This is this roll of 5. And then now we'll go through the current continues through this resistor. And now we're going to connect this row to a ground and to complete the circuit. So we'll basically simply just drag it from that hole to this pin. This pin is a ground pin, right? This is the physical pin 246, right? Physical pin number 6. Okay. So now we have a circuit. If we're going to output a high voltage, which is about 3.3 volts, it's within the range that's recognized as a logical one, right? So that will output some voltage here, and it goes, the current flows through this LED, through the resistor, and to the ground that completes the circuit. Okay, so this is our Hello World circuit on a breadboard. Now, when we build this out physically, this is the design part. When we build out this physically, again, as I mentioned, we're going to use this will be connected to an extension cable, and then we'll have that GPIO extension on the breadboard, and then we're connecting to that. So, but for our design purposes, we're just going to assume we're connecting to the Raspberry Pi directly. Okay. So that's it about using Fritzing to design a circuit. And then we've just designed. Now, this file so far has not been saved. So you actually can save it. Just Control S. And the default location is under documents, freezing. That's fine for me. So I'm going to just put it over here. Just name it and say, hello, .fzz, right? And then we're going to just say, we'll save it. So that's it. And then if you want to, so that's we'll close this. And then want to work on that thing again, you open this app. And now it will remember the recent sketches. I click on this. It will load up this file. This is what we had before, okay? So I hope this is helpful. Thank you.